I just hope that this day is fruitful for all of us. We had a good session yesterday. I think things picked up quite well in the afternoon, and there was quite a lot of energy in this room that we got to see, and I hope that we are able to create that same energy in our discussions today. Just a few details I wanted to talk to you about. What we have done is we have kept notepads at the rear end of the room, and in case if you wish to make, if you want to pass on a note to the advocates, then please feel free to do so. You just have to get the notepads from there, and you can send your pass on your comments and questions to the advocates. We have few volunteers who are happy to carry the slips of paper to the advocates, and also water is served out right at the rear. We are making arrangements to have coffee set up outside, and so these are a few things that I just wanted to share with you. I think people are still trooping in, so we'll probably give it a minute or two, and then we are ready to start off with the discussions, and I'll ask the advocates to start calling their witnesses. Okay, thank you so much, and I hope this turned out to be a useful session for all of you. Thank you.
Your witnesses are here? If the witnesses are here, we can start, because we don't want to be late.
Give it 2 minutes and then start. I mean, yeah? Okay.
Can you hear me? Good morning, everybody. I hope we are ready for we were promised it's going to be a very heated discussion today, not like a bit the early stages of yesterday. So we are looking forward to start our debate today. As all of you know, yesterday we covered the occupancy profiles and the cooling approaches. We went through the delivery on promises, and then we had a very interesting discussion on the financing of cooling projects. Today we are covering cost and the end user, and addressing a very close subject personally to my heart, which is safeguarding the environment, health and safety issues, and then the water and its availability, which I'm sure everybody knows in the region. It's a huge critical problem. So it's going to be a very interesting session for everybody. We're going to start the court today with the standalone system lawyers to begin the first session. So we call this court started, please. And just to wake you up, microphone. I don't think the microphone is working.
Hello. That's better. Yeah. So you've got Mr. Zaka, who is the General Manager of NIA. Zaka, we believe that you've been doing some research on residential type air conditioning installations, district cooling and standalone systems.
We cannot hear you, Paul.
No? Sorry. You're winding me up, George. Yeah, so we believe you've got some case studies on residential applications between district cooling and standalone systems.
Indeed.
And also you've got some views on the sort of general populace on air conditioning with respect to a lot of people can afford district cooling at these exorbitant rates because they're higher paid at a higher level in society, whereas the general populace do struggle with these rates. So perhaps you could please...
I object, because we installed district cooling in labor camp.
George is in the hierarchy, so George doesn't mind paying the district cooling rates. He can afford it.
We put it in a labor camp, I said.
But with the rest
how can you go lower in hierarchy than this? This is the lowest you can go.
George is at the top. We all aspire to be as high as George. Mr. Zak.
Thank you very much. Assalamu alaikum. I would like to say this because Madam Judge has insisted that we should have a heated debate. I would still like to keep the peace with district cooling, because I sell more than 500,000 tons of air conditioning in a year. More than 500,000. And very few people know my company, because we sit in Dubai and sell all over the world, the biggest market being Iran. I sell brands like O General, which is very popular in UAE, and it also is a #1 brand in Iran that keeps 40% market share. We built this over a period of 20 years. I also sell Hitachi, from rooftop package units to centrifugal chillers and absorption chillers, which are used for district cooling. And we also sell Yazaki, which is a solar chiller, what you call as a pony chiller, with a 30-ton capacity, used for solar-assisted applications. Like you could use it for 20 or 30%. And we are favored with the first trials and approvals by Masdar for that product. So I would like to keep my peace with district cooling. I sell equipment. I don't care where it goes, whether it goes into a standalone or a district cooling system.
But we don't want to keep peace with you.
Well, this is what I said. This is what I said.
It would be one-sided peace.
When I want peace, since
let's
I
just
carry
focus on the answers, please. I appreciate it's a good opportunity to talk about our own companies and our expertise, but let's just try, please, to keep as a witness, just to address the questions and get on with the answers.
Thank you.
And George, when it's your turn, you can talk as much as you want. Thank you.
Been told. So, yeah, could you maybe comment on the rates with respect to society in general, the population, and
Sure.
who could afford what, really?
The other point that Madam Judge said yesterday is that we should focus on the subject, so I do not want to divert too much into green and water. I would speak simply about 2 points. One is the cost, which is economics. The other one is end user, which is affordability. I would first like to speak, before I answer Paul, because you mentioned about labor camp. An end user may be living in a labor camp, but the payment is made by the company. A labor camp may be in DIP, which means they don't have a choice. They are forced to use district cooling, right? So an end user, you will have to define more in terms of demographics, in terms of the social status and affordability, rather than simply saying that, oh, this is Burj Khalifa, you can put what you want. Now, end user, if you say, in the case of district cooling, if he is living in Discovery Gardens, and if he has to pay even 20% more than normal electricity, it's a burden on him. But if the end user is living in Emirates Hills, and even if he has to pay 50% more than electricity, it's an advantage to him, right? On a standalone system, he will have to put all the rooftop package units and the condensing units on the roof, and he will use a very valuable space. For a Emirates Hills resident, if he goes for district cooling, he can free up that space and he can put solar panels for harvesting solar energy, or he can use it as a roof garden. But if you burden somebody living in Discovery Gardens, it is quite unfair. That's for the end user. The second thing that I did on the matter of cost is there has been a lot of talk yesterday about Emicool, a very ardent and very, very professional guy, highly passionate about his business, and he said that all the challenges that he has taken. So I took one villa from the green community, and I found out what of their cost in real terms. You can contest it and say that it is not fair. And then I also took from Meadows, which is using a DX system, and I compared the energy cost. On average, district cooling is costing 1,400 dirhams a month, and DX is costing 1,100 dirhams on the running cost.
These are based upon actual utility bills? So
yes,
this is based
in fact,
yeah?
That's the other instruction I got from the Madam Judge yesterday, that we don't talk simply about personal experience, we produce evidence. The evidence that I have produced is empirical. You can actually go through the details and arrive at your own conclusions.
I've got copies of the bills over there, so they can be viewed by the opposition if they like. Yeah.
And the second thing that I did is, since we have a small contracting company, I took a normal 4-bedroom villa, and I said that if this villa has to go district cooling, what is the equipment and what is the cost? And same thing if it has to go for a normal DX system, with constant speed compressors, which are not very energy efficient. And I compared. In the DX system, although we use only fan coil units, the first cost is about 98,000 dirhams because the piping that we use is very expensive, copper tubes, chill water. Whereas in the DX, although we use compression units, the costing is only 73,000. So there is almost a 20% saving on the first cost. But then again, you can argue that this equipment will have to go change once in 10 years. On a 20-year life cycle, the cost would be more.
Can I request that you give us kilowatt-hour consumption rather than money? You said 1,400 compared to 1,100, and this depends on the rates, which is not fair. We just need kilowatt-hour consumption if you have.
Yes, I do. In fact, if you take district cooling, since you use only fan coil units, your kilowatt consumption, the input power is only 5.5 kilowatt. Whereas in the case of DX system, it's about 55 kilowatt. So the power consumption in DX is more. But I have to agree that since I did not take the cost of district cooling per ton as GPM, I did not do that study. But if I am recalled again after about 30 minutes, I can produce that for you.
I don't think we need it. At the end of the day, what people see is the cost. So I pay a bill. So if we're comparing a like-for-like villa, all I want to see is the cost, irrespective of what the system efficiency is, because I'm paying. So I don't care if it's the least efficient in the world. If it's cheaper than the alternative, that's what I want, and it provides the conditions that I want. So I don't think efficiencies really come into the costs, because that's what people see.
Not the efficiency, is the charges per kilowatt hour. And if that camp was in Abu Dhabi, it would cost less than 1,400. So to be fair on all, we need, it's better just to compare, and we can get out the kilowatt hour of the compressor out of the board.
Both residences.
Can I respond to that? Can I respond to that?
Yeah, please.
Look, at this conference, we cannot discuss about the cost, what is the cost in Qatar, Abu Dhabi, and Dubai, right? We are now questioning the ultimate wisdom of a developer or a district cooling company which partners into going into a project knowingly that the end user is not benefiting on cost. That to me is extortion. To me it is extortion. So it doesn't matter. District cooling could be applied in Alaska, right? In Dubai, if a customer has to pay more than 20% for energy, it is unfair. For a guy who is living in Discovery Gardens, you cannot justify his plight by saying that, oh, if only you were in Abu Dhabi, your cost will be 30% less.
We are. Both the villas are in Dubai. They're both of the same size, so we are comparing like for like. Yeah.
Well, however, I concede that we are talking about two real-life situations. We do not know the lifestyles of these people. We do not. I know the demographics; they are similar. They are Indians. They are a family of 5. I know that, but I don't know. Maybe for one, the comfort condition is 21. The other one, the comfort condition is 25. But by the law of averages, it could be real. The comparison can be very close to real, much better than what your consultants have been doing by putting safety factors, everything.
The question is this, no, this is very good, because this is where the fruitful discussions will lead. Now I agree with you that this thing, as you said, differs from one country to another, but we are here discussing a problem to have a better future by finding a solution for it. So without knowing the kilowatt hour, then it has no meaning. Why we are saying district cooling is not good in Dubai? Simply because the charges are too high. So we are looking for that price to go down in Dubai, and this is the ultimate for the future. We are not discussing what has been already built. We are making benefit of the experience that we got from the experience from the previous project to make a better future for the district cooling and the generations who are going to use that, in case it is possible. Whether it is also, maybe we will favor the standalone. So So the comparison, when I asked for it, it has a base for the future rather than what had been taking place now, which could be fair, it could be unfair. And also there is a lot of a human error in it, as you said. One family will use 21 degrees, one family uses 25. This is just an approximation to give a feel. Thank you.
Sorry, all we're saying is that this is a good indicator because we have bills for Emicol for one villa, and then we got the DEWA bills for the other villa, so we have a comparison.
I would like to respond to that.
So we have actually a hard evidence, yeah.
Look, I think our advocates at the opening remarks have very clearly said that we are not against district cooling. The advocate said that all that we are saying that for a specific application, there is a specific solution, right? Now, if you take district cooling for a vertical development with a high density population, it may be economically viable and also environmentally friendly. But if you transpose that onto a low density population in a horizontal development, to me, that is not feasible, right? But that again depends upon the end user. Somebody living in Emirates Hills will pay anyway, happily, right? That's my point. So I do concede that the comparison taking real life is not fair. If we want to do apples to apples, we have to actually take the tonnage of the villa, average use by whatever standard that we say that normally we use 10 hours a day as an average. We can do that, and within about 30 minutes, if you wish, I can come back and give you that information.
Main equipment.
Can you repeat that, sir?
You applied any diversity factor
In what, sir?
in the villa?
No, since I took a real life situation, I didn't have to apply the diversity.
Why?
You apply diversity if you are taking a nominal value. You don't apply in a real type situation because diversity is already there. Right?
We're actually comparing two active systems installed and operational over a 12-month period. So, with your permission, I'd like to just share these utility bills with the jury. Okay. So, if I can perhaps show you these. This is the first cost. This is the first cost for the district cooling standalone. This is the utility bill for district cooling, and this is the utility bill for standalone. So we can look at the monthly costs and the first costs. So we have the information available, and that's what our discussion is about today. Our point is that standalone systems are operating cheaper than district cooling systems. I think we rest our case and leave you for cross-examination. Thank you.
Zakir, I have to apologize from you because I have done thousands of feasibility study and you'll be in bad spot now from you from the beginning. Okay, you just mentioned the labor camp in Dubai Investment Park. I say we did two labor camp by choice in Abu Dhabi. One was 40,000 laborer where we put 12,500 ton, and the total district cooling cost, internal and external, for 12,500 ton came to 120 million. And they started with 330,000 square meter. They extended to 450,000 square meter without adding to the plant room.
Objection, madam. We don't bring, yesterday we agreed, we don't bring personal experiences or personal studies.
Yeah,
I would also like to clarify that.
And there is a second camp, a Rayyan camp, and now the owner has done two other camps with DX were smaller, and he saw the big saving in infrastructure, basically in the electrical part. The same will apply to the villas. You said the difference in kilowatt was 50 kilowatt, and the saving between air conditioning side, DX air conditioning alone, and chilled water air conditioning alone, correct, we don't object to that. 95,000 for the chilled water and 75,000 for the DX.
That's the first cost.
First cost. However, the hidden costs are The 50 kilowatt cost the villa electrical work around 1,000 dirham per kilowatt, which is 50,000 dirham additional. And the infrastructure for this villa will be another 50 kilowatt at 1,500 dirham per kilowatt, come to 75,000 dirham. So there is a hidden cost of 125,000 dirham that surpass the saving that you made by 6 folds. This is where people don't see, and I have to educate myself to know what is the total cost of a development rather than AC alone. The third part, I agree with you that on energy part, it is the district cooling last year was sold at 49 fils per kilowatt per ton hour for the green community, while the average electricity, which I have a villa even 500 square meter, came to 22 fils per kilowatt. Now, if I work your ratio back, I see that the DX has consumed 1.75 kilowatt per ton based on that. And the cost per ton then will come to 38 fils per ton hour. And that's because in Dubai, the slab rate is favoring inefficient and small equipment. This is just to cross-examine the evidence given to the jury and to highlight the difference. We as a society has failed to create the right condition for district cooling. It's not the district cooling company who put unfair rate to the end user. It is the utility that created unfair rate to district cooling and penalized the users of district cooling. Would you agree with that?
George, you are a very good advocate for district cooling. By asking a very loaded question and also without giving any gap between 3 subjects, you are trying to win advantage to yourself. Let me please segment this and respond one by one. Right? When I spoke about labor camp, I was talking about the end user. I was not talking about a facility. You said labor camp is the lowest in the hierarchy, which is not true. The lowest in the hierarchy is a gentleman living in a studio apartment in Karama or in international city. That is the lowest hierarchy. The guy living in a labor camp, everything is paid by the company. He is not paying for the utility. That was my argument with you. It's not about the facility. The second thing that you mentioned is the comparison of the villas. I took comparison of villas in Dubai, and you say that the average cost is 22 fils. Not really. The people who are living in a 4-bedroom villa, they pay a very high premium for their energy.
For that, I measure my own villa for the last 3 years, and my average came for 22 fils, and my villa is 5,000 square feet.
The difference, George, I am not bringing my villa and your villa for discussion. I have provided you with actual evidence. You should study that before you make a cross-examination.
We will. I mean, if
please do that.
I will take it and study it and come back later.
Please do that. Yeah. And the third point that you said is the cost per ton per hour, 38 fils. That's what you said. I would like to come back on that subject and address it when I do my calculation. I'm not prepared to respond to that right now.
Okay. That's it. Any clarification regarding? Shall we, just in the interest of time, can we come back later to that subject?
Sorry, I have a question. I haven't seen the bills yet, but in your comparison, have you, in the district cooling example, have you included the capacity charge in your cost comparison?
Yes, sir.
Do you think that it's relevant to include the capacity charge when you're comparing basically a consumption-based sort of?
Look, I'm approaching this subject in a reverse direction. I'm a commercial person. I'm not engineer. I'm not a consultant. I'm not working on this on a hierarchy of top down. I'm looking at it from an end user's point of view. Right? Now, George said in the discussion that because the energy consumption for district cooling is less, you can save 150,000 dirhams on the provision of electricity, right? The cabling and the substation that you have to do. But as an end user, I don't know if I have already paid for it for the substation that is used for the district cooling. If you are providing power to me, you must be providing similar, not exactly, maybe 30% less power to the district cooling. That goes to the cost of the development, and that will be amortized on the cost of the villa that I buy. So you're not actually saving, maybe you're saving a portion of that.
It was paid by the district cooling company, just to clarify, the electricity connection fee. Okay. In Dubai Investment and Green Community, they charge MECO the proportions they have used out of the substation.
Thank you. That is why I appreciate this debate. And I sat through here yesterday because there are a lot of things which are misnomers and we don't know. The main value of this debate is education. There was so much to learn. I thank you for that. It was my understanding that the developer would be paying for the provision of electricity. Thanks for that. But the point again is this. I'm an end user. I go and pay for a villa based on a market value, not knowing what it took to build air conditioning system, not knowing what it takes to build a district cooling system. That's what I pay. But that is my first cost. I do it for emotional reasons. But the real cost comes on the maintenance of the villa, the running cost of the villa. But when I see that the district cooling is costing more than a normal utility bills, I feel the pain because the jury asked me, have you taken the connection charge? When you say a connection charge? Capacity, which means it is a minimum slab that they impose?
The ongoing fixed charge?
That's right. I have calculated that, but you have to, because when the district cooling company takes that fixed charge, and then anything excess is charged on actual consumption. That is cash out of my pocket, so I will anyway account for it. I don't look at a bill as an engineer, as an end user. I look at it as how is it impacting my budget?
Then is it not appropriate to consider the life cycle cost when you are adding into the comparison the capacity charge? Then you should see the life cycle cost.
Which I did. When I did the costing based on a life cycle, a standalone system would cost me 10% less than district cooling.
You mean including it's got a 10-year life cycle?
20-year life cycle.
The standalone system, you mean?
What I did is, in the case when I calculated the life cycle, I took 3 costs. The first cost is of course the first cost, that is the cost of the equipment and what you pay to the contractor for the pipes and installation. In the case of district cooling, I took it as 1 for the space of 20 years because this equipment can last that long. But in the case of unitary product, which is a standalone system, I took that cost as twice because compression technology doesn't serve for that long. I anticipated that we may have to change it twice, so I took it as 2. As far as the running cost is concerned, I told you it is 1,100 and 1,400 dirhams a month. I calculated that by 12 and 20. And as far as the maintenance is concerned, I kept it flat 5% per annum for both systems. So when I computed all together,
sorry, you mean maintenance? See, the cost to the end user for a district cooling is just the charges. The end user is not responsible for the maintenance.
No, I'll have to clarify to you. A district cooling company doesn't deliver cool air to your room. It delivers a chilled water to the connection point in your villa. From there onwards, you have to have your own internal network to convert the chilled water into cool air to your room. So there are equipment involved, right from the heat exchanger to the fan coil units and the controls. That is where the first cost of 98,000 comes from. And that equipment will have to be maintained.
So the maintenance here is on the secondary line, it's not on the primary.
Correct.
So is it correct to assume the same percentage of maintenance for both systems?
Well, there are certain things in the industry that we do by a thumb rule. And the thumb rule for maintenance is 5% of the first cost.
I can comment on that. First of all, we want to thank him for coming up with such figures to start with. And that was a start for us to have this discussion. And if he had made some small mistakes or he didn't take anything into consideration, this does not cancel the fact that he did a nice job. Now, he is not an
Thank you.
engineer. He is not an engineer, and he did his best. And to answer your questions, the 20 years is the right approach. But he also took into consideration that he has to replace the full DX system after 10 years. So he was fair on that. You raised two other points, which also are valid. Number one, you cannot assume 5% of the initial cost for the district cooling. It should be half of that compared to the DX system, which is a commercial versus industrial type. So that is something which you could probably in the future make a little difference. And 2% or 5% of what? What is the cost of district cooling? Is it the chillers or the total, including network? These are the questions which will improve his study.
But he has mentioned that it is only for the secondary equipment.
That's right. I took 5% of
the maintenance. He didn't take the maintenance of the district cooling itself, which apparently that would have been inbuilt in the capacity charge.
Well, I understand. I'm saying when he did that and he assumed the 5%, that 5% also increased the cost, the indirect cost for the district cooling. So that we can also take it as a node to modify his or enhance his study.
That depends who is the owner of the fan coil units in the buildings. Probably it's the developer, not the
that is no money, because the whole fan coil unit price is $200, $300. So that is
the pricing. Whatever he has mentioned now and what he has provided the estimates, it is based on the fan coil unit equipments installed for district cooling. It's not based on the cost of the district cooling plant itself. It's not the cost of the chillers.
Is it that way?
Yeah, and I also...
that is then 5%. Yeah. But did you actually added the possible running cost other than the electricity, which is the 5%? And the 5% of the district cooling is the price of the air side, while the 5% of the standalone is the total system, right?
No, I actually learned this from you, sir, yesterday.
Yeah,
you said the maintenance cost is 5% of the first cost, so I took your word for it.
Yes, very good. But this is, we just want to make sure that what he did is a base for all what we are talking about now, which is quite good.
Here you mentioned 20 years.
Yes.
For the secondary loop, this 20 years or more than that?
Which 20? District cooling is over 20 years.
Okay, means over
25 could be 25, could be 30 years.
Or 100%, because this part from the conversion. Because if you're going to tell me you will replace this DX unit every 10 years, means we can, if we compare with the secondary loop, maybe 30 years or 40 years. We need to
No.
I don't know, but I need to highlight it only. What is the life cycle for the secondary loop? If we're looking at the conversion between the DX unit and second
Can I respond to that?
The argument, your argument is correct, but if you know that the total
clarification of argument, I need to know what is real conversion for the life cycle between the DX unit and the secondary.
Just 20 years, because we don't need the rest of it for a simple reason. You could end up with a plant that lives 20 years if it is...
I'm not talking about the plant room. I'm talking about the secondary. His base is here for the secondary loop only.
No, the secondary loop is 10 years for him, which is the fan coil unit, is also the same thing. That's why it is 5%. Once he used the 5%, then it is all. But let me just explain to you, since all of those things are estimations and calculations, you do not need to bother about the total initial cost simply because it represents 5 to 10% of the life cycle cost. So no matter what you do, add up or come down, it will not affect the final figure he got to. You could imagine how much is the electric bill of a standalone. You said it's about $1,100 a month?
That's right.
Okay, say $1,000 a month. So you 12,000 a year. In 20 years, you have 240,000. Just the electric bill, $250,000. And how many tons approximately that place? Approximately.
37 tons.
37 ton. 37 ton. And how much is a ton sold in DX units in the country here? 4, 5, 3?
Well, the installation cost, you can divide
the initial cost of
you can divide
DX.
78 by 37, so it's about 2,200 dirhams per ton.
So 78, you got the figure. So you also have 78 over 250 just for the electric bill. It is more than, it is less than 25% or 30% of the electric bill. So the electric bill is how much? 300% of the initial cost. No matter the fluctuation of 10 or 20 or 20 or 22 or 25 years will not affect his monthly bill. This is what I wanted to come up with, because there is nothing 100% correct. This is an indication. Yes.
With due respects, I would disagree with the technical. Again, I am coming from an end user. If I am building a 4-bedroom villa in green community, and if the developer insists that I have to take chill water from a district cooling, then I will be compelled to do this study. And when I do the study and I realize that a standalone system is costing me 10% more on a 20-year horizon, then I would say, why should I submit myself to an autocratic system of a district cooling where I don't have the flexibility? Whether I use a single unit or I use a 10 unit at a given time, I have the diversity, I have control, I have flexibility when I have a standalone system. With the district cooling, I have to pay a minimum slab of 839 dirhams, even if the whole building is dead, right? So I would consider. Now, to answer the question of the juror who was here, he said, why 20 years? For any study, you have to accept certain fixed factors. The agenda has clearly dictated, calculate the cost based on a 20-year cycle.
It's actually spent. That's what actually recommended.
That's what the argument, right? So we took those factors exactly and arrived at a 10% saving on a standalone versus district cooling.
Thank you.
And was that on a present value basis or on a nominal cost basis?
It's on present value.
In the sense,
actuals in each category. Actual. Like I took the price of ME Cool, whatever it is today. It may change 20 years time, I don't know. I took that they were present. What happens in the future, we don't know. But any...
No, what I mean is, were all these cash flows discounted back to present value to arrive at a comparison between the two options?
That's correct.
And that gave a 10%
advantage to standalone.
25%.
No, on the total cost it is 10%, on the running cost it is 25%.
Any more questions?
Mr. Zakir, we appreciate your efforts in bringing the actual bills. They are all very raw data. When you are working the kilowatt per kilowatt rate, we'll appreciate if you provide the like-for-like breakdown of it, so that it will be more easy for us to understand.
So I have to clarify again. I felt a study on real-life situation for the purpose of this discussion is more valuable because it gives a better insight into the real cost. Because as we discussed yesterday, most of the things that the industry, I don't want to identify consultant, most of the things that industry does is on a thumb rule. And we heard from the district cooling providers yesterday that if you go to an MEP contractor, he says it is 9,000 ton, whereas in their calculation it is 4,500 ton. The reason why this happens is, if I am the consultant, I would consider a worst situation. I have to provide comfort to my customer when the ambient temperatures are 52 degrees Celsius. I would assume at that point that all 10 air conditioners will be working at the building at the same time. Right? I will not consider the averages. You may have 8 months of normal temperatures of 35 degrees Celsius, but you have 4 months of 52 degrees Celsius. So a consultant will design to the peak, and he will consider the worst condition. Right? So if you take that, I can do the comparison. It's very easy. It's just a multiplication factor. But I think since there are so many professionals from air conditioning over here, they have to take the insight of the end user and design and select a system that is favorable to him. It shouldn't be because since Nakheel is in the business of property development, they say that, okay, let me also go into district cooling and I will force it onto my buyers. It shouldn't be like that. Union Property said that since district cooling is being done by Nakheel, I also want to do it, right? It shouldn't be so.
Zakir, just I use this time to do analysis on the bill. First, the standalone villa had 71,000 kilowatt hour, and the total electricity bill came to 18,123 dirham per year, or 1510 dirham per month. The assumed 1100, you assume 73% of that go to air conditioning.
Yes.
So just to understand.
75% actually. Sorry, actually 70% is what I assumed.
What I got is 73% was assumed for air conditioning. And I did the calculation of the cost of kilowatt. It came to 25.4 dirham per kilowatt. Just to correct. Fils, sorry, 25.4 fils. Which means that district cooling, again, the standalone system ton hour costed around 38 fils, or it will come to around 1.6 kilowatt per ton, which is reasonable on a year round. The second one on the district cooling side, what is amazing is low consumption. Out of the 1,400 dirham bill per month, 814 dirham went for capacity charge or fixed capacity charge or demand charge for the 11-ton villa. Only 586 dirham per month was the average consumption, starting with 100 dirham per month in winter months and reaching, despite that the rate for the district cooling was 48 fils per ton hour, which was much higher. What we see here is that how the end user, when he's being paid on meter, how much he took control of his consumption of the AC. It's amazing to see these low figures, which comes that if I took the energy alone and compare them, they are, despite that ton hour is 30% more expensive, yet his usage was less than half, which tell me something that the end user or the human behavior, which always highlighted in World Bank when we meter, and this will be the subject of cost later with our sub-metering guys, that how much the human factor, once he's aware of these costs as standalone cost for cooling, went for self-conservation. Just I'm analyzing your bills, and thank you for bringing them over as again. And sorry, I'm good in numbers.
Thank you for that. But I think just now he lost an argument against himself.
No.
Because if this guy is the owner of that green community is so aware of the conservation and he is consuming so much less, but still the total that he is paying is 300 dirhams more than the next guy. So which means if his consumption is on par with the other guy, then the cost of district cooling will be much more.
Just for education of the jury, the 888 dirham per ton charged by Emicool is returning the capital cost, which when they built these villas, the construction cost of that project went down by 8 or 9%. And the payback, because these were villas, the piping cost us, I did the design and execution of this. Normally in district cooling, the piping cost 2,000 dirham. For these villas costed around 4,500. And so the total cost of ton was 12,000 dirham. And the payback will not be in 15 years. That's why Emicool is suffering. So you have to understand, when we compare, it is easier you invest more in a villa. But as an end user, you might be right, because there's no laws that differentiate. So what we want to make aware the end user, whenever you buy into district cooling, you should buy 8% cheaper than a system of standalone, because it costs 8% less. Just education.
Yeah, let me clarify for the juror one thing. When we spoke about the energy, It's very important. For the DX system, the villa, it's the center of the power. It's the center of providing and distributing the cooling. It means that my DX unit is there, but district cooling, the center is of the district cooling. So for villa served by district cooling, we are using only fan cool units. That's why the energy is very low, versus a villa using stand DX system is the energy for fan cool units and energy for the outdoor units. So that's the energy. I think we should not take that in consideration. We should take an overall system and use. And I think what even Mr. Ghalbi said, the study is accurate as it could be for the time, for this study. Is accurate as it could be, I think. This is a very important point. Thank you.
Thank you. My submission is that I was simply doing costing from the end user's perspective, not from the developer or the designer. Thank you very much.
Thank you very much. Let's just to be aware of time, the whole session should end by 12:25. And I appreciate that we have at least 8 witnesses between the two of you. So, you know, we'll try to make it as effective as possible from a time management point of view. George, would you like to call on your first witness, please?
I want to call Mr. Hans Altman, if he's here. Hans, would you, Hans Altman is the managing director of Tekem Middle East, where they are responsible for metering, and they have these as investment, they are investment companies that handles not only turnkey solution of metering, billing, actual billing to the client, actual investment, actual sales. So they are one of 2 turnkey supplier along with Jarmo on metering, and they have done a great job in promoting sub-metering. Hans, would you agree with me how much, and you did study from yourself to confirm when cooling is metered and billed separately, that the end user will go and conserve dramatically on his cooling?
By all means.
By how much? And share your experience, please.
Well, if we talk globally, savings of an average of 25% are normal. To talk locally about our own experience here in the UAE, in Dubai, we have achieved 22%.
And when this is metered, the awareness that it creates and the fairness viewed from the end user that he's paying for something that he knows.
It is awareness, and it is cautiousness. I can give you an example of one building that from the moment we started billing, the month after, automatically the cooling cost, it's a chiller operated building, was reduced by over 20%. Just knowing that you have to pay made the people aware of their consumption and reduced the consumption drastically.
So you're saying that when I have standalone, maybe I might not pay as much attention to the AC.
For us, it's a bit different, with all respect to your definition of standalone and district cooling. For us, as a utility billing service provider, we have a shared utility in the building, and this is what we consider. We don't differentiate between standalone or district
regardless.
Okay.
It's a joint utility, shared utility in the building.
But I'm saying, suppose somebody has a DX system and his bill is common. He doesn't have separate electric bill for the ducted split in his villa. He has one common bill. Of course, he would be careful for AC. We're not, but I mean, being diluted with other element will not highlight how much he's consuming in AC.
It is electricity in general, and people know that AC and split units run on electricity, so there will definitely be cautious and careful with their consumption. Because if you have split units, you have the advantage that you know your consumption. If you have no metering for joint utilities, you don't know your consumption.
Okay, but even in a villa, the consumption of the DX is combined with water heaters, with lighting, with other electricity load. So our witness has to assume that this part goes to AC.
The assumption is done, well, if I may talk from my own experience, because I live in a building, in a villa with split units. It's very simple. Compare the winter bill to the summer bill.
But in winter you have hot water.
But
can we stay away from assumptions and focus on facts and figures, please?
Fine. I mean, that's all from our side. If you want to cross.
I guess, Hans, and based on your experience for the using BTUs meter or whatever, I think the metering system, it will bring awareness for a system, regardless if it's a standalone system, you have a chilled water plant at the building or the district cooling. The factor here we want to emphasize in both cases is when you have sub-metering or shallow metering, regardless, it's electrical meter for DX system that is gonna just give you an idea about your electrical bill for the AC, or BTU meter is going to for district cooling. I think the fact having a sub-meter or shallow meter is going to rise the awareness within the end user and push for energy conservation. I'm going to share with you the international level study on the United States done in New York State. They show that by having shallow meter, it's 10%. That's it, proven, it's posted. So here it's 20%. At the end of the day, I think it's not only for district cooling, this is applicable for district cooling standalone. Thank you.
On my side, I said, but I know that you also can meter the refrigerant, or you are not in this business.
refrigerant of what?
Even if you have a DX system, you can measure the cooling capacity.
Okay.
You could have meters for that also.
Okay, let's put it like that. Everything is technically possible, but when it comes to practicality, we have to see where it hurts and how you do it. The principle of billing of a joint utility is the cost. We don't go into energy units in kilowatt hours, because if we go there, then we end up somewhere else. We have, for a joint utility, the common platform we talk and we allocate is cost, cooling cost, money. Because at the end of the day, it's money that counts. Whatever the meters read, kilowatt hours, tons, megawatt, whatever it is, this is just a unit. But this is transformed into an allocation. This is an allocation tool to go for money. So if it goes to other things, yes, they're doable, but it is about the economics of how it is done.
Yep. Thank you very much. Thank you. Shall we get you next witness, please?
Can we call Francois?
Our witness is Francois Bouhari, who's the president of Deakin McQuay. So, Francois, before we had Mr. Zakir, who was giving us a comparison of district cooling to standalone for residential buildings. You have a similar experience, but with respect to commercial establishments, buildings. So could you perhaps follow the same track as what Zakir said, and just give us a description on, or some feedback on the differences between the two?
Yes, thank you. So in this case, we're going to talk about an end user being either an office space owner of a multi-story building, sub-renting or subleasing to various owners, offices, a hotel operator, or a residential building, okay? The capacities can be between 1,000 or 3,000 ton for that structure. If we do air-cooled chillers, that would not be very efficient. water-cooled, we all established yesterday with Hussam that the technology for district cooling, if that owner is willing to invest with operators with money, can benefit that. I'd like to focus though, however, on VRV, because I see a lot of skepticism about it, and it's a new technology that people should become aware. It's very efficient. I mentioned yesterday 1.28 kilowatt per ton. That's actually an average. We could even go down to 1.11 kilowatt per ton on one of the sizes at 46 ambient Middle East conditions. For those skeptics, in May, ARI will be certifying this data. We've been working with them in the US, where we would get 0.8 kilowatt per ton on 95 degrees Fahrenheit. How is that possible? Well, people 15 years ago asked how district cooling was possible. So, you know, engineers, when they look at it, Daikin is today a #1 leader in the world by size and by technology, and has been investing a lot in inverter technologies, in magnetic bearings and drift technology. So everything is possible with the right technologies. We have done case studies on installation profiles. There's also always part loads. Always there are part loads. That's a reality of life. A hotel does not get full occupancy year-round. There are always empty rooms, and that cycles, either seasonal or with economy. There's also a speed in which an office building gets occupied and leased, right? So it's not always full load. It's not always what companies end up paying to a district cooling provider for whatever load they need in 5 years' time. From day one, they have to financially survive, both on first cost and operating cost and maintenance cost and flexibility to change internally the design. So VRV provide these things.
Just to clarify, so what you're saying is that a VRV system can adapt to variable occupancy and to part load conditions. So it could be a compounded situation. You could have winter months where the building is fractionally occupied, so you're operating at quite a large turn-down ratio.
Yes.
Yeah.
Yes. Also, who of you here in Dubai or in Abu Dhabi or Kuwait or Riyadh would not like some heating in the cold winter days that are relatively cold when you first wake up? VRV is a heat pump as well. So you're getting heating for the same cost of an air-cooled system, plus, minus, or less. So depending on the architecture of the building, that's the limitation of the VRV system. You have to be able to find the space for the indoor unit, the outdoor units, because they're about 30 ton apiece. So that's how you have to think about it. So with proper planning on the architecture, you can fit out those outdoor units, but internally the flexibility is amazing. You can basically do everything internally, where with water systems you're limited where the pipes are existing. Copper pipes are very easy to maintain. I've heard yesterday, oh, what about leakage? Well, natural gas is distributed in Europe. That's a disastrous leakage if that happens. With right technologies, with right technicians, with right training, which we are providing to all our installers that we sell to, the accidents don't happen.
Could you maybe touch on the metering? I mean, if you've got a VRV system within a building, how you would actually meter individual units?
Yes,
maybe
yes. Actually, VRV has a built-in BMS smart system. So you can actually identify the meter consumption for individual units. How is that possible? It's because, if you think about it, it's a very smart system. Outdoor unit communicates with the indoor units on a constant basis, okay, on an ongoing basis. It's all inverter driven. So the outdoor fan, the compressors, the compressor per unit, the indoor fans are all inverter driven and variable speeds. The expansion valves, they modulate as well, and it all communicates back and forth. That system also helps, so you can assign the power output for the outdoor unit and the indoor unit. Let's say you can have one outdoor unit serve 20 units, but they're shared between 2 tenants somehow. You will know this tenant, what he spent per month, even per hour if you want, both for the outdoor utilization and the indoors. And cost does matter for people that are paying and sharing. Otherwise, it's not sustainable. you will have people fighting. I did not use my office. I was not in my apartment. This month, with this billing system, it's fair. Fairness is sustainable.
Excellent. So in summary, a VRV system will adapt to part load conditions. It will do heating, and you get metering all within one system.
Yes.
Sounds a far better alternative to
And Europe, one moment, Europe where utilities and electricity is not subsidized like it is here. The market has gone for VRV in many applications. It's not the answer for everything. The size and the application matters. District cooling definitely has its very big implications and applications as long as the load and the plant match. That's really the key.
And in terms of the installation time, is there any disadvantage on installation time over a conventional, say, chill water system? You mentioned before the pipes are smaller, so in terms of time, is there any drawbacks from that?
The only drawback for VRV is not knowing, fear as well, skepticism. It's a system, so chilled water contractors dealing with it the first time, it might cost them more time, but once they know it, it saves them actually time and overhead and speed.
Very good, thank you. Salah, any questions?
Francois, it means, based on your experience, you are the president of Dakin McQuay here in Abu Dhabi. I guess you have experience with the local. The reality is, district cooling penetration in this country, it's about 20%, maybe 25%, 10%. Okay, that's good. 85%, 90% of the area are not covered. We see all the north states that are not. So what happened to the customer who has a building in that area? People, they get blindsided by the short term. But this is the reality. 10% of the area is covered by district cooling. 90% other space, they have to use a standalone system. Regardless, it's air-cooled, VRV, water-cooled, whatever. And that's the reality here. How, based on your experience, how we can deal with this fact?
In what sense? In making it more green?
You know, we object. We're not here to argue that a standalone building all by itself would not have a standalone system.
Sorry?
We're not here to argue that a standalone building wouldn't have a standalone system. If it's in the middle of the desert, we're not going to put a district cooling plant.
Okay.
So we don't need it.
Okay, thank you. That's what we want to put. It means that's the reality. We have to deal with it. Thank you.
So I've got a couple questions. So you're going to put a VRV system, any standalone system, is going to be sized for the load that you're provided, based on the load profile, correct?
Sure.
And it's an accurate load profile. They did a perfect job. I designed it. So it's perfect.
I'm not sure about your design, but I assume it would be.
No, I made the estimate. I could do that. Okay. So, as you said, hotels aren't full all the time. Convention centers aren't full all the time, those kind of things.
VRV is not for convention centers, sir. Don't take me where I didn't say the application is. Okay.
Let me rephrase. A hotel.
Yes.
Or a building that I own, I'm going to rent office space. Some of it's occupied, some isn't. Occupied during the day, not at night, things of that nature. So the efficiency of the VRV system, it's always, you said you could approach 1.1
at full load.
Okay, so what is it
46.
at 50% load?
It gets better.
Gets better. What is it at 75% load? Gets better?
The IPLV of 1.26 can be equated to about, sorry, the 1.1 at IPLV would be about 0.8, 0.9.
Okay, all right, so you're...
Air-cooled system, sir. Yes.
Agreed, okay.
Just clarifying. VRV can be water-cooled, it even gets better.
Okay, all right, we'll give you that. So, we're talking about metering. If I utilize the metering within the VRV system, what's the accuracy of that? Is it billable, truly billable, or is it divisible, if you will?
Can you explain more? What
Yeah,
you mean?
if I put in a water meter, I would expect that water meter to be a 0.5% accuracy.
A water meter?
Yeah.
Okay.
Can you agree to that? Could I issue a bill that is that close and that accurate?
Yes.
And how do you do that?
Because you can actually, the VRV is an electronic-based system that would measure the flow of refrigerant to each individual unit.
In what way? How does it measure?
Because we have electronic expansion valves that communicate constantly to the outdoor unit. And based on that, excuse me, let me finish. You asked the question.
Okay, and I'll...
So the indoor unit, so there's 20 indoor units, let's say. They communicate to the mothership upstairs, okay? They say, I need 10% of your capacity, and it sends 10% of refrigerant, okay? So it's a modulating. So this is why it's called variable refrigerant volume.
Okay, and we're not arguing variable refrigerant.
Okay, so
what's
when,
the accuracy
when
of the
you
meter?
vary the refrigerant, you can measure the volume you're sending. Based
on what technology? How are you measuring? The fact that they communicate, you and I communicate, but if I communicate in language that you don't understand, or I don't have accurate data, you can hear it, but so what?
I don't understand the BTU meter technology, but I would take your word for it.
Okay.
Okay, so take my word for it, or we can present all the data you wish and measure and compare.
I need to know it's accurate enough that I could truly bill. Being able to...
This is skepticism, what you're providing right now, but we can sit in the building and measure.
I trust and but verify.
You are welcome. We can provide you with a lot of buildings to measure.
Okay.
I would say that the same way you measure chilled water on the liquid line before the expansion valve, you could get the flow rate.
We're not arguing about what you could do. We're talking about what they are doing and saying that they could do. Okay? And we're not doing that, correct? It's not a direct measurement with a flow meter.
It's measuring the flow of refrigerant. That's a measurement of flow.
Okay.
Per unit, per indoor unit.
Agreed.
And then the assumption is there's
we just need to see the data. I would need to see it to trust that.
I can make you a believer. Many were not believing before.
That's
if you're open, if you're open-minded.
We are open-minded, my friend. Good. That's why we're here. Okay, thanks.
The jury, any comments?
Sorry. Considering we're still on the issue of cost, could you throw some light on what the difference between the upfront cost of installing a VRV system versus, let's say, a connection charge for a district cooling system would be? Or just, if you can just provide a upfront cost.
I'm not a specialist in this facts, but I think there's a colleague, if time allows, could cover that with 5 minutes. I don't want to make mistakes. I have the data, but I would step over them, so that's not my specialty.
Can we ask for just 5 minutes to bring the data? Josh, we bring a specialist. So, okay. That's fine.
Yeah. Thank you.
We call Mr. Majid to give us some...
No, it's district cooling's time now.
No, we ask for 5 minutes just to follow up with the idea, bring in the numbers.
Okay, he's gonna, okay.
Yes.
To follow
Sorry,
up
we
the
thought you need 5 minutes.
Thank you, Francois.
Extra.
Thank you.
I'm not going to take too much time. I'm just going to present a quick case of G+7 Barsha hotel, a hotel in Barsha, which we studied the different options for. So on initial cost, the VRV option would cost, it's 1,020 tons, done with HAP calculations, everything done, so it's load profiles are taken into account and everything. The initial cost of a VRV system for that particular building was $2.25 million versus water-cooled chiller costing $2.89 standalone, air-cooled chiller costing $2.47 standalone again, and district cooling would probably cost in terms of connection charge, first-time cost, around $232,000. And then you'd have to buy that low-side equipment as well. that would cost somewhere in the range of $1.4 million, so a total of 1.6. Cheaper for district cooling. But then going forward, when you calculate the VRV electrical consumption cost per year, and I'll just focus on the VRV because I think that's the subject of the discussion now. Electrical cost for VRV was in the range of $325,000 per year, while the consumption charge for district cooling was $527,000. All taken into account with the operation and maintenance cost. A simple first cost plus running costs for 20 years for VRV would be in the range of $9.8 million, where district cooling would be $16.8 million. However, when we do net present value, to answer your question, VRV would be in the range of $6 million, while district cooling would be in the range of $9 million, 50% more. Thank you.
Yes, the number, if you want to share the numbers that are available, we can share it later on. It's a fact.
A couple of questions. You've taken this over 20 years?
20 years.
And how many times does the VRV system get replaced in this?
I didn't take that into the calculation due to the fact of time, but even if you replace the VRV system, 10 years down the line, you'd pay another $2 million. That's if you replace the whole system. You're probably going to only replace the outdoors. You pay less, and that 10 years down the line would equate to maybe $1 million in net present value. The difference is $3 million anyway, so $1 million, take it.
And, sorry, on the district cooling, the 527,000 includes capacity and connection charge.
On the district cooling, which number you were saying, 527, it includes capacity and connection charges at a rate of 0.48 dirham per ton and 800 in terms of capacity charge.
Just yesterday we mentioned a question, or we asked the two parties to maybe help us identify if there are certain applications that is applicable only to district cooling, same with standalone systems. So maybe by presenting a new technology, do you think maybe we can, in all our sessions, but maybe we can start now to address such question?
Actually, we've used the VRV system on a G+40 tower, 3,000 tons. Still doable. In Japan, they use it for high-rise buildings. So the system is not limited. It's modular, so you can add as many modules as you want.
Thank you.
Majid, you said it's 1,020 ton?
Yes.
No, are you answering the question?
Yes, I thought I did.
1,000, that's for the hotel, sorry. 1,020, George, 1,200, that's for the hotel in Barsha.
This is not what we are looking for. We are not looking capacities. We are specific applications that you believe and consent to the fact that standalone is not recommended here, period. Or district cooling, like Mike said, I am not going to put a district cooling for a building sitting alone in the desert. So this is something like this. We don't want to limit it to capacities or number of stories and things like this. It's just when a project is announced, you consent that this is not recommended to be a standalone system from its specifications, a complete specifications rather than just capacity or number of stories.
Mr. Ghalib, we tried, agree with you, but for the purpose of the session, we try to bring hard numbers for case study regarding the cost and the end use. That's why we brought Mr. Majid here. It means to...
I want to cross-examine these costs.
This, by the way, it came while we are discussing the cost.
Yes.
But it is not intended that it is just a reminder for you. We need that list. Both of you agree. We requested you to give us that list.
Okay, thank you.
I had to
thank you.
Take note.
And I want to just, this analysis was used by using software, HAB software. It's available on the computer and we can share it. It's shareable. We worked on it this morning. We unplugged the data. These numbers that I provide by Majid are, we use it, the numerical tool, it's HAB. software.
I am convinced that there are applications in Medina al-Munawwara where hotels, 3 hotels with VRV working for many years now, and I have the data for them, and they are more than 30-story buildings. So we are not talking that this is good and this is not good. As we said, everyone has its own
merits,
field and application. We just need you to enlighten the end users and the consultants that yes, these are recommended to be this, take it for granted, and those are recommended, take it for granted. And this is a gray area where both will fight. That is for sure. Yes, sir.
The first yeah.
We're not against this, they're not against this.
Again, I will take your stand. I always recommend VRV on high-end application. We are believers, myself, in VRV, and I'm recommending it anywhere, particularly in bedroom, where it provides ultimate comfort, very similar to high-end chilled water with modulating valves and modulating airflow. So no doubt the VRV provide a superior comfort level, and people who knows me knows that I recommend it every time I can for standalone, in particular for bedrooms.
And I'm a district cooling veteran also, so
but I will cross-examine your assumptions. Again, you are in bad spot. First, the hotel is 21,000 square meter. In district cooling, for us, that's barely 600 to 700 ton, not 1,020 ton compared to VRV. So district cooling will always fail whenever we compare 1 ton of traditional AC to 1 ton of district cooling. We recommend 70 to 80% district cooling because there is diversity into that, unlike the standalone system where you need to put standby. Again, from G+7, when we did chilled water with fresh air and exhaust, our cost came to around 1,200 dirham per ton, $1,200 US per ton. I will take the 700 ton, that's come to $840,000, not the $1.6 million as internal capital cost of the internal system. For high-rise 50 and 60, we are reaching $2,000 and $2,500. But for G+7,
that's including the heat exchanger, including the piping pumps, everything.
The heat exchangers, many district cooling provides that, and many times it can be direct connection. So G+7 is borderline. So when we did a project like that, the second thing, I mean, you are assuming that the cost of VRV installed is $2,200 US per ton. And whenever I'm taking actual quotes, sometimes they are reaching $3,000, $3,500 per ton.
This is actually derived from a BOQ that's priced, so we can share this.
It's a contractor price, or your?
It's a contractor price.
That's what you have a solid contractor price.
We have a solid BOQ done by a consultant and a contractor price to support it.
Sorry, just for the benefit. What happens sometimes, contractors that don't know VRV, they assume the percent cost is the same as chillers, and then they add a black box number on top. You end up with a crazy number.
No, that's fine.
This was priced by a contractor who's very well equipped with VRV.
That's very
he
good.
knows his job.
Again, I will not only use the same argument against you, against him, Zachary. He ignored all the electrical costs. And in such VRV, even if I take 1.25 kilowatt per ton, so you still have 1,300 kilowatt, and for G+7, it's around $500, $600 per kilowatt internal work, so I have $800,000 on top. Plus, I have a connection fee that comes to, again, to let's say, I would estimate electrical work on top of your cost of $1 million US. So now we are comparing almost $3.2 million US to less than $1 million for district cooling. First cost. And in particular, district cooling in Dubai is in a bad spot because of the slab rate, and that might give big advantage in terms of consumption, no doubt about it. But I mean, the prime mover of district cooling is really capital cost. And second, I mean, there is also a comfort zone. Typically, I mean, hotels, rarely people goes for standalone system. They still prefer a strong preference of comfort zone towards chilled water. It's like the motel in the US where they put these individual packets. They are considered inferior quality. So I'm with the superiority of VRV comfort, no doubt, again. But I'm saying there is a comfort zone that hotels mean chilled water. Hospital means chilled water. Mall means chilled water. It's choice of building. I mean, it's the first thing that come to people's mind is that.
I think you mean in the Middle East.
In Middle East, yeah. Correct.
Here. It's not the same anywhere else.
True. I mean, I'm talking
it's a
just
misconception again, or people are just skeptical.
I mean, that would change, and in time, like Lebanon does not believe in chilled water. VRV, I mean, has big time there. Yes. Surprisingly, I mean, this is the only technological advantage that happens there. But you are right. I mean, even in Middle East, we have countries now. VRV becomes the first thing of choice for high-end application in office building in central Beirut or in villas in high-end places. VRV is considered the trend today there. Thank you.
Thank you. Thank you very much.
May I take a couple of minutes on this? My question is not limited to this gentleman sitting there. My question is generally limited. I mean, my observation and specifically a very small question is addressed to both the parties. Now, since morning we are sitting here, and I am an end user. I use district cooling, I use standalone systems, I use variety of window ACs as well. And we have generally observations on all of this stuff. I understand that the focus of this discussion is ending up being a purely analysis of the cost comparison of the various, or the two different parties. I think VRV is coming in as a more of a distraction. VRV is a technology that can apply to both, whether it's standalone or district cooling. I think there's no debate on that. Now let me throw a little bit of spanner in the whole works. Since we're getting into so much detail of the cost, including did you consider net present value, what is the life cycle, how many times you're replacing, I have a simple question. Now based on the first argument that came, Emirates Hills versus somebody else, where we actually observed, if you compare the consumption charges only, the district cooling is far cheaper compared to the DX system. The whole advantage, energy advantage of district cooling is getting eaten away by the demand charge, which is 839 or whatever dirhams per ton. And that's where we are getting, the district cooling side is getting beaten up in terms of the cost comparison. Now we can fine tune all these assumptions and we might have an apple to apple comparison and say maybe variation is 10% or 5%, whatever. My question to the district cooling side is, if I were to, one of the advantages, as you say, district cooling is not 1 ton of standalone is not 1 ton of district cooling, it's 0.7 or 0.6. If I were to actually estimate my air conditioning tonnage requirement of a property as 1,000 tons, which is again a peak requirement, and typically because if I were to put in a standalone system, I would install 1,000 tons because I want a safety factor, etc., or maybe a little bit more. But when I'm going for district cooling, I actually am not taking liability onto myself or the risks onto myself. If I were to sign a district cooling contract instead of for 1,000 tons, for 700 tons or 800 tons, and I still go and pay the penalties or whatever when I consume more, can we do a cost comparison based on that? So when we are taking 1,000 tons for standalone, but 800 tons for district cooling, and then look at the financial numbers and then make a decision? I
have done thousands of studies. And
so is that something that we should be looking at rather than doing?
You know, when we started, 95% of the consultants were against district cooling here. Same happened in the US. Because it was new, and we tried to do a lot of analysis, we found that consultants don't like to take the chilled water plant away. So they try to fight it with numbers. And we had an uphill battle in the beginning to convert probably more than half the consultant now become either neutral or in favor of district cooling. It took an upbeat battle. I mean, they beat us on every number. I had ulcer in my stomach after leaving these meetings, and even bringing contractor quotes and this, they were skeptical. So despite that, we proved the case for district cooling feasibility, and it was always a developer, because he's saving 8% on construction cost, which was the biggest selling point. And the lack of availability of power and the lack of space. For example, Shangri-La want to put a tennis court. Rotana Hotel converted because of noise. It was creating objectionable noise to them. Other people connected to district cooling for many combined reasons together, besides the capital cost saving. But the prime mover for end user, against the advice of his own consultant, was not, he went for district cooling, and against the advice of his consultant, he accepted that we can give him 70% or 80%, and if he need more, we can give him. Why to commit upfront? So now it's becoming an acceptable fact from from the developer. Even yesterday, I had a case. He brought me a consultant design of 1,600 ton. I convinced him with 1,100 ton. That's what he need. It is also, I mean, the district cooling is really guilty in not promoting the actual measured data into the field. The breed are hiding this data. Not only that, the worst part is that they don't measure, they don't care what square meters they are serving. And this is, I say, where we are guilty as an industry and defending that industry, that we are not using this data in our favor to benefit the end user. Sorry.
Okay, do you want to respond to that? Or we just move on to the, because we are already, the time of this session has ended already, and I'm
just, Madam, just 1 second here. I think the load estimation, any designer needs to understand the load. If you design an energy efficient building, we should be going above 25 square meter by ton. A minimum 25 and go up to 35, for example, if you could. Maybe 50, that's something, that's the trend, what Ashram 189 want. But let's assume the reality from infrastructure, we go between 25 to 35. And later on the frontier it's 50. And this should be applicable for all systems. When you assume, because the space load is the load, but what it changed a little bit on the system selection. When you select heat exchanger.
When I design, and even I go to Dubai municipality or check in Istidama, the software itself has safety. Yes. We take coinciding weathers 115, 85, that again increase load by 10%. We also assume certain things and certain occupancies that doesn't occur. Even myself, as a very conservative designer, I end up oversizing by 30%. And I wouldn't dare on standalone system not to give my customer the standby, the case of failure, the case of lack of availability, the effect of time and deterioration. So I don't say, I mean, while in a central plant that are well maintained, and you have, you can assume one standby, if anything happen, you always have a backup plan, centrally rather than standby in every building. And this is the major advantage from capital cost of view of district cooling. This is a major advantage. Nothing makes it more favorable than this.
I think the debate here is when we speak cost, it is cost to who? George is discussing cost to the district cooling provider. Very fair. But we should be looking at cost to the end user.
That's the whole idea of this debate. Yep. It has to be all, you know,
I focused end user.
Yep.
And you know, the biggest thing, when you move the plant out of a building, you reduce total construction costs from 8 to 12%. Sometimes infrastructure like horizontal development include infrastructure on top of cost on the end user as well.
So when the end user comes and asks for 1,000 ton, the district cooling provider advises him to take only 700?
That's what I always
sell
did.
The 1,000.
That's what I did, and I think some of the district cooling, you are correct, are not advising or pushing enough. They are giving Hague a kind advice. If it is more, they get more money.
Yes.
So it's against their commercial interest to reduce. And I think the role of third party is very important now. It's very important now to involve specialized third party that can give the right advice and save tons of money.
I agree, but George, not all designers are ready to take that risk and work at the gray area, the boundary. One rule of thumb, we learned it in this business, they said, we never take somebody to the court because he oversized the system. But a lot of people, they went to court because they undersized the system. And this is that one of the driver on the industry.
I object. I don't know of any case of either thing happen in this country. I'm not aware.
Yeah, but I'm talking, overall, we talk at the universal, at the international.
Here, practical. I mean, I don't want theoretical assumption. I was part of one case that went to the court, Ubaidli building in Abu Dhabi, and the court could not deal with it, neither under nor above.
But the problem, I said, the problem, Mr. Ghalib here, maybe he's gonna step here. The fear, I understand, the designer should be working at the frontier, should be working on the boundary with the new standard for energy efficiency. But the fact that the industry practice here is there is a fear factor. People, the designer, are not ready to take that risk, work on the boundary. Maybe DC Pro are doing, but I'm not showing that all the designer on the fact are doing this.
Yeah.
We must differentiate between the lack of regulations that govern the behavior of the consultants and the end users, and the fact that any design must be to the standards. So if there are consultants that misbehave, it doesn't need to be the fact that we should talk about it. We should talk about the proper design regardless. Now, when it goes to the court, it's a matter of regulations that the judge himself also, he has to follow within a boundary of laws. And if the laws themselves do not govern the relationship, then it doesn't mean that this application is bad or good. It's a lack of having proper regulations where we need then to fight to get such regulations implemented. This is very important to differentiate. So we want to talk about the ideal system regardless who does it. Now, if it is not ideal and you want to take the consultant to the court, then this is a regulation. This is number one. Number two, I don't think the taking to the court and penalizing the consultant whether he undersized or oversized the system has any meaning in a practical life, simply because all consultants are poor people. No matter how much big the consultant firm is, when you go to sue them, there is nothing you can take out of them, even if you sell his share. But if you talk about a contractor or a developer, that is something different. Therefore, let's just ignore this, taking him to the court, educating the public, educating the consultants.
Sorry, Ghalib, a correction here. We have a professional indemnity insurance that is 25 million.
Correct. So what is 25 million on millions? I understand.
True, but even that, you need a court order for the insurance to pay. Yes. And the courts here are not complex enough in the Middle East entirely to deal with these highly technical cases.
And that's why they do not go to the court. I am in arbitration business, and we always take construction contracts disputes to ADR, alternative dispute resolution, outside the court. And this employs highly professional engineers to solve the problems. This is important. The fact that you do have an insurance doesn't mean that every consultant will have it, even if he wants it. Even if he wants it. The insurance companies have to make sure that your office is capable of doing a proper design. Otherwise, they are not going to gamble and give him insurance. 50, and what is the other 50? They take most of the jobs, the other 50, because they are cheaper.
No, that's the reality. That's the sad reality. That's the sad reality. We are compromising the quality of having accurate sizing versus because it's cheaper.
So it's a matter of regulations.
It's a matter, no, it's a matter of education, skills, and regulation. All of them.
Your Honor, we still have one witness. Do we have time for that still?
I don't think so, no. We are already 10 minutes out. Unless you are going to cut your witnesses for the next session short, then we will do that.
We'll do 5 minutes witness, final witness.
Okay, thank you.
Thank you.
Thank you.
Can we call Mr. Jarmo Hikkanen, the General Manager of Metering Division of Camstro, please?
So we'll try to make this really short and sweet. What's average cost for a standard office space, standard apartment, say a meter for, you know, apartment this size, 2-bedroom, kitchen,
the price of a BTU meter for a flat.
BTU meter for a flat, yeah. BTU meter for a flat, small office.
Roughly, say, €100, plus installation, of course.
Which equates to what in dirham?
Including installation, about 1,000 dirham, perhaps.
Yeah. Yep. So if we had 10 users, we would have 10,000 dirham, roughly, as an average.
Roughly.
Okay. And what's the stated accuracy for your meter?
Okay.
2%? Well, 0.5%?
Well, it depends on the it depends on a lot of things, but we are talking about percents. Yes.
Okay. So the information that comes from your meter, what all is included roughly? I mean, it gives you diagnostics for the meter itself and for the calculator, the meter, all the devices?
Yes. When I mean, when we are in a metering business, we are always measuring somebody's money. And in European Union, for instance, the authorities get interested when somebody is measuring somebody else's money.
Are they interested here?
And there is no regulation in here yet.
Okay. So at this point in time,
for BTU metering, but for instance, all the suppliers, not only us, but all the suppliers from Europe, for instance, fill the requirements of the local authorities' regulations, and the meters are type tested and initially verified before they leave the factory.
Agreed. So that metering, you try to comply to any requirements here, which there are limited requirements at this point in time. Are there plans for more requirements for authorized billing?
Quite often what I face is that in the time of purchasement, the say contractor or the consultant or even the client by himself, they are referring to European regulations. So they are widely used in here as well. But there is no such a law in here which is regulating BTU meters as such. Whether they are even needed or not.
Yeah.
Which is a funny thing in my opinion.
Okay, so in order for you to market a meter in Europe, it has to first go through and be a qualified meter per the agencies, the regulators, those people. Is that fair?
Well, I mean, to start from somewhere, I mean, if we take a typical flat in a tower, they pay, could it be 500, say 300 dirham for electricity, 300 dirham for water, but they will pay close to 1,000 for cooling. And there is quite some regulation for the measurement of water, quite some regulation for measurement of electricity, no kind of regulation for measurement of cooling energy. And this is This is somehow what I find a bit peculiar. And then again, I mean, in my opinion, one of the things that is perhaps, as seen from a consumer point of view, drifting district cooling away from the individual consumer is that pretty often chilled water suppliers try to keep away from the individual consumer.
Okay, so the bottom line is that it's really unregulated at this point in time.
This is for
the district cooling, or the cooling in general. It's always been. Do you agree, as a person living here, do you agree it's been something that was just an add-on to your rent at one point, and then it became part of your electric bill, so it wasn't an issue. Now that we're starting to segregate and actually want each person to pay for what they use, do we have those regulations in place for cooling?
Decision of whether having or not measurement is done by the client himself.
Yeah.
And if you don't have any individual metering, I mean, there is no energy conservation, and thus no savings for cooling energy, which is the energy that we use most in this area.
Okay. I have no other questions.
Hi, Jono. We don't question the fact that metering has its benefits, whether it's a standalone application or a district cooling application. It brings about incentives for the end users to reduce energy and an awareness. So really, as a witness, you could act as a witness on behalf of the standalone.
For sure.
You're welcome here, because whatever merits you bring to district cooling, you also bring to the standalone case as well.
Yeah.
But yeah, we understand the merits and welcome it as well. Yeah, thank you.
Thank you.
Can I ask one more then? Because that's true. But let me ask you this. If all you want to do, if all we're trying to do is make people more aware, do we need any accuracy?
Yes, we do. I mean,
repeatability is required, correct? You want the same number always as you measure, but the accuracy, does it matter?
Accuracy, yes, and some kind of a system that secure that you really are using equipments that are tested.
Right. So the bottom line, I want to cut this short. The bottom line is that if all we're trying to do is to get people to be more aware and try to reduce that number from a big number to a smaller number, any measurement can work. But if we're actually billing real usage, we need accuracy, correct? Okay,
yes. Thanks. And I think that, Your Honor, you were yesterday pointing out a question that we were, at least yesterday, discussing about efficiency of chillers and efficiency of this and efficiency of that as one unit. And I think that seen from the end user point of view, the overall efficiency is what really counts. And I mean, this is my favorite, that I mean, what you don't measure, you cannot manage. That there has to be measurements in the input and output of the system what you use. I mean, whether that is standalone or district cooling, it doesn't really deviate at all. But in order to cut down the energy using and encourage the energy conservation, the individual has to be measured. Because I mean, Hans gave figures 22%. I have one case in here which I can deliver to you if you wish, stating 45% savings in real cases in Copenhagen for district heating after installment of individual measurement instead of bulk metering.
For the system, not
for... For the energy usage of a building. It is a dwelling house.
Yeah, a total system for the building.
Yeah, no, energy usage of individual living in this apartment.
So it's in a dwelling.
It is remarkable savings, what we are talking
So it's a
about.
whole system for that.
See, there is a difference between parties who work on the development of the equipment that is sold to the market. Their field and research is totally different from what an end user will see.
Right. But all he's saying is that if you install a meter and people start to watch, each
see as much as 45% saving by an individual inside of a building.
That is that's a human behavior.
Exactly, exactly.
That is definitely yes.
Yeah.
But what I wanted to clear is from chatting to some of the audience at different levels, you can see how everyone thinks and what it drives him. What it drives the end user is the end result. A sales engineer, and you can see, George, what happened the other day is a sales engineer sells the chiller per ton, right? And that X amount, I don't want to declare the figure, is almost 10% of the cost of the end user, the total cost, because he sells the chiller per ton delivered to the job site, while the end user cares about how much per ton is going to cost him. And it is 1,000 times the price. 1,000 times the price, including installation, warranty, spare parts, and operation and maintenance. It's just a horrible figure. Therefore, if you save 10% in the efficiency of that chiller, 10%, how much is going to affect the total cost on the end user? It's related to the ultimate operation and maintenance and the electric bill for 20 years. And this is where it is magnified 10 times. This is what we wanted to come up with ultimately.
Yeah, thank you. You know, we're going to end this session now. I was hoping that we would have time to give you 5 minutes to stretch your legs. I don't know if we have this time. So I think we're going to jump into the next... Sorry?
Call the guy from
Yeah, well, if, you know, I appreciate it has been a long morning. You have, sorry?
Safeguarding environment.
Okay. If you, and George, how many witnesses you have for the next session?
I think in total 7, but 2 will not show up. So we are 5. We have 5 that are actually here.
Oh, okay. Well, we need to maybe 3. We need to go down to 3 if that's possible.
Possible, yeah.
Okay. So if this is the case, we have 4 total witnesses. We can do 2 before lunch and 2 after lunch. So maybe we can have 5 minutes just to stretch your legs. Okay. But 5 minutes exactly, please, because we're definitely going to start at 5 minutes past 1. Yeah. Thank you.
Who won it is the one of Mexico City. And when I see these 2 sides and their nomination, I was impressed what they have done regarding the main focus was energy efficiency and renewable energy. Like the mayor of Toronto is proud of deep lake cooling, is proud of his tri-generation, is proud of his solar initiative that he to put on top of every city. I see the mayor of Brisbane in Australia, where he put every 500 meter he put a bicycle station in the city for bicycle rental. He's putting renewable energy for even ships that sit at the berths of. But what is impressive, the drive toward tri-generation, co-generation, district energy in all sorts that is topping the list. And I'm starting to believe in city mayors, not in politicians. I was sharing that with that politician is like moving a big elephant. They are scared to put nationwide policies. Look at Dubai, for example. They put the green building regulation on stages and they pull it back and they are reluctant. Same in Abu Dhabi. They put the regulation of istidama, then they pull it out. They said it's stopping building. Politicians are afraid, are scared, are not courageous enough. I think we need to focus on city mayors. I think it's easier to move a city. That's one aspect. The second aspect, today 50% of the people of Earth live in cities. It's predicted by 2050, 75% will live in cities, in urban cities. And cities will become the prime mover of the Earth. Not only 75% will live there, but probably 90% of the world economic activities will happen in cities and around them. Just to share this, because now we are focusing on environment, this is our strongest point. Our weakest point, the guys get advantage of us in the morning, was cost. I acknowledge that. Now we're going to show our muscles.
Okay, I think we need to start. So you're going to wait for your colleague? Yeah. Because you have only one witness. Do you prefer to keep your witness in the middle? Or you want to start?
We are open. We work at the open book. We can start with one witness and we can develop it later on.
Yeah, please go ahead.
I think Paul has other numbers and names here.
Okay.
Okay. We're going to call Mr. Rami Al-Khalil from JGB to the stand. Mr. Rami, please. It's JGB. It's
we are an equipment supplier, actually.
But he's on the Ashri. Mr. Rami Khalil is also
Good
one
afternoon,
of the
everybody.
PUG's member
Hello.
of Ashri.
Please.
Okay. Yeah. And we're going to start the second session there. And the question is, Mr. Rami, based on your experience in dealing with the project and district cooling, oil and gas, etc., one of the important aspects that we are seeing today during the commissioning of district cooling is the water dumping to the environment and the level of iron within that water. We know that the international regulation has a specific target, and unfortunately the practice here is a little bit not in line with that. Could you elaborate more what are the solutions to provide that, and what are the period, the time frame?
Actually, from a supplier point of view, we are just helping consultants in, giving proper selection of equipments and systems. Regarding district cooling, we are in the business of water purification. We find out for district cooling, we use a large amount of water to flush the system. Okay, when you flush the system, there is a certain amount of allowed certain amount of Fe and some other TSS solids around, required to be around 2 milligrams per liter in some of the restrictions, like maybe I've read something like in EPA about 2 milligrams per liter for the iron existence. But while we are doing here, I have seen some projects. What they do, they flush and they dump it directly to the landfill or to the nearest landscaping or to the sea. Sometimes many of the consultants have a regulation to take it, filtrate it once a time, and deliver it back to, dump it to the sewer and then to the sewage treatment plant. That is a different issue. It gives a solution. But when you dump something like that in the so many systems we have inspected, they have around 18 to 20 milligram of iron in the first flush of that one. That's a very big amount of iron. When you dump it to sea, and if you dump it to the landfill, it causes a lot of environmental impacts on things. To do such application and filtrate that water, now some of the consultants, they have regulations. They are, about the developers of district cooling plants. They instruct the contractor to filtrate the water, maybe 1 cycle, 2 cycles, we don't know, and then dump it to the either sewer or landfill or to the sea. We've done a study right now to one of the projects that you need to flush around 8,000 cubic meter of water, and the existence of iron Fe in the system was around 20 milligram per liter. In order to filtrate that amount and dump it to the sea to the level of 2 milligrams per liter, you need 5 months continuous filtration to the system. Then after that you get around 2 milligrams, then you dump it to the sea or to the landfill. So I don't know how many, in this country, or how many district cooling provider or consultant or maybe owners, they do the same application. Do they filtrate really the water with the correct number of cycles and then dump it back to reduce the number? That is the real point available. I don't think so. 80–90% maybe they don't do that. Maybe Mr. George, as he's in district cooling, he can advise what he's
maybe about his thoughts about this issue, whether he is instructing their contractors to do filtration properly and then dump all those kind of, all that water to sea or landfill, etc. For sewer line, most probably you don't have a problem if you dump like this much, but you need really to filtrate that maybe for 1 month, like a number of cycles, then you dump it back. Then sewer plant can take care about the other issues. But finally, sewer plants are also dumping to the sea in some of the cities and countries. That is the major concern, in this.
Let me here to emphasize, 80,000 cubic meter for...
8,000 cubic meters.
Sorry?
8,000 cubic meters for flush water, first flush.
No, what should be the size of the district cooling?
8,000 cubic meter, I don't have an idea exactly.
The cooling capacity of the district cooling.
I have no idea about the cooling capacity, but 8,000 maybe cubic meters, somebody can advise here about that. But it looks big, one.
Okay.
To have that much.
So for an 8,000 cubic meter of flushing water, we need at least, with a normal filtration, water filtration.
With an optimum system to just a filtration, optimum one, without inflating because it's cost money also to filtrate that much of money.
We need 5 months.
If you have an optimum design, you just let's say for example, add an optimum design, don't filtrate 400 GPM. So for example, if you filtrated 200 GPM per day, you're going to end up with 5 months continuous cycle, then you are allowed to dump it to the sea or to the landfill.
Sorry? About 30,000?
Yeah. One of the experts.
Okay, the hijam over there. Okay. We are talking here, George, it's a minimum plant with 30,000. We need 5 months to meet the international regulation for the flushing.
Yes, and for dumping the flush water in landfill.
Just to be in line with environmental code from flushing standpoint. And we understand one of the critical aspects, like we spoke yesterday, is the commissioning. If we don't do proper commissioning, the system will be derated and we will never meet the right efficiency on the evaporator side, on the condenser side also, not for the cooling.
Energy is a matter of heat transfer. So if you have have a good heat transfer equipment, whatever it is, you need to maintain it properly, flush it. And one of the systems, like between the standalone, I don't want to take much time, but maybe in 1 minute, between the systems for the standalone or district cooling, end of the day, you need to maintain your heat exchanger inside in a proper case.
Yes.
In so many buildings, the maintenance is not proper, is improper. Nobody is cleaning properly with the proper material of cleaning, actually. And
okay. Another point here I want to also emphasize quickly is, when we have a district cooling system, one of the major problem is Legionella.
Yes.
Legionella problem in the cooling towers, it's critical. Unless you have a proper filtration, double filtration for the water from physical and chemical, and we might, and the level of temperature, we might end up with a risk. Particularly, we saw a number of design people, they put some makeup units very close to the cooling towers. And also here, unless you give a particular attention to the treatment of the cooling tower, how you're going to deal with it, you're going to find out that your cooling plant became a hazard source.
Yes, of course.
It becomes a serious hazard
Some of the plants you need
for the fresh air getting to the building.
You need to add the chlorination in one of the stages to filtrate the water and to kill some of the bacteria like Legionella. There is a design stages or filtration requirements. Some of the, contractors or some of the, let's say, consultants try to skip some of the system equipments required, maybe unintentionally or intentionally, because of cost, because of etc. Because if you add, you need a higher filtration system, you need to add some chlorination, oxidization, etc. So those are required. When you miss some of the system, then you decay your system efficiency. So I emphasize on Mr. Abu Sa''s comment that about suing the consultant who's doing bad designs. It's the idea of, we need to learn them, educate them. That is the proper thing to do, actually, because unfortunately, a lot of them,
Close.
From my witnesses in the market, there is some consultants who really don't define between two-way valve and three-way valve. They really don't know where to put that and when to put that. Unfortunately.
Yeah, I agree with you. Now, the focus is, in one word, there is a healthy issues with a cooling plant, it's more in district cooling or even dedicated plant, unless you deal with a couple aspects. your cooling plant could be a source of health hazard.
Of course, we need to study the environmental impact because in all system we have an entropy, and that entropy in our system is kind of environmental impact. So that needs to be studied.
For us, thank you.
Thank you very much, Salah, for giving me the time. Thanks, everybody.
No, stay there.
With him, but you stay there.
Okay.
Now,
You can't get away that easy.
this is the first on the safeguarding the environment.
Yes.
Okay. Did we define how to save the environment? What are the elements you talk about? Is it only power consumption? Is it water? Now that is the safety and health is another issue, which is you were talking about now. But let's define three things. What do we mean by safeguarding the environment? Is it only ODB? Is it GWB? Is it TEWI? All of it? We need to talk about it. Then you need to tackle three of them, okay? Not only one. Okay, so we need to talk about three of those when we talk. And for those who are all of you aware of ODB, GWB, TEWI, or you need the definition?
It's good, you good.
Can you?
Okay, ODB, ozone depletion potential, which has to do with the type of refrigerant you use.
Yes.
GWP, global warming potential, has to do with the power consumption at the power plant, which is the rate of emission of CO2. That is related to how much power you consume.
Yes.
TEWI is a measurement that takes the two into consideration, which means total equivalent warming impact, TEWI. To be able to measure the effect of your system on the environment, you need to know how we scale and measure the effect of ODB and GWP. R11 was the one taken for ozone depletion potential being the highest, and ammonia NH3 was taken as TEWI because it is 0 ODB and 0 GWP. And every refrigerant after that is rated with points compared with the 0,0, which is the ammonia, the ideal refrigerant. Now, on this effect, I like all of you to challenge the witness and the advocates when they talk about these three elements. We need to talk about them. Now, safeguarding, this covers the safeguarding the environment. When you talk about health and safety, this has to do also with the type of refrigerant, the controls and the safeties used in the system, what a grade it is, comparing a commercial with an industrial type control, and the water, which I don't think should be involved in this thing, although, as you stated, it has a big issue on the health, because anyone can challenge that this water is used with standalone and with district cooling. So no matter, if you want to say no, it is dominating the district cooling, we can argue the district cooling as air cooled. So we don't want to enter into the business of this, although we need to highlight it to the end users that what are the effects of using the TSE, okay, which is ultimately, okay, we want how it is going to affect the environment regardless, whether it is localized or centralized. So we close this subject.
Okay.
And please take this into consideration.
No, let me add here. I'm gonna take a couple minutes. When we talk about environmental aspect, I agree with you. We're gonna talk about ozone depletion, going back to Kyoto Protocol, or go later on.
We object. You are eating our time.
Huh?
We object because you are taking.
No.
time.
We go.
We
back
have to
because,
cross-examine.
listen, I went through health and safety real problems. I'm gonna go back and close the loop. When we look on the environmental aspect, we look at the holistic approach. It's about conserving natural resources. We know the challenge in this area. We have the highest energy consumption in the world, correct? About 18,000 kW per capita. We have the highest water consumption in the world, 550 liters by person, correct?
Because also we have one of the highest...
Well, that's fine, it's 75 in the industry. We have also the highest waste, solid waste generation. It's almost 1.7 kilogram.